When we develop, we're dealing with source code, and we're talking about text files that hold hundreds, if not millions, of lines of code. And when we talked about the software development workflow, we talked about the fact that it's nonlinear, and a ton of developers are touching that code at the same time over a period of time. And when that happens, we run into a ton of problems that we need to address in order to be effective and efficient when we're developing software. And in some of those categories that we run into are accountability, the chronology, in other words, how things happened over time. And then we talk about change management and just how important it is. So in this video, we're going to talk about the problems that arise due to the nonlinear nature of the software development workflow. Now that we understand the software development workflow and the fact that it is not a linear process, but instead we have a bunch of changes that are happening all over the place by various software developers over a period of time, and that all of these little changes that are happening are impacting probably the same source files that hold the code that makes up our software or our applications. And because all of this change is happening, and because it can be happening to the same files, we end up with the potential for a lot of conflicts and a lot of problems and a lot of issues that can arise because software development is not linear. It is all over the place. With that, what we're going to do in this video is we are going to jump into the issues that arise because software development is nonlinear and because everybody is working on everything at the same time over a period of time. Once we understand the conflicts and issues that arise, these problems, we can then better understand the different tools that are provided to us within the software development world to manage these issues. So let's dive right into the issues that we run into because software development is not linear. The first one we're going to talk about is a lack of accountability. Now, as we do this software development and as the software engineers are pulling tasks and beginning to work on those tasks and begin to develop software, modify software, or create new features, they're going to be writing in these software files new code, and that code could pertain to similar features that other developers are working on. Now, as they're programming and they're checking in code and they're testing it, one issue that we run into is this lack of accountability or the theory of accountability, in that if we don't know who made what change, at what time did they make that change, we really have no context around the change that was made to our system, which means it becomes extremely hard to discover who made the change, but also the reasoning behind the change. And we also don't know why a defect was added to the software because we don't know the context surrounding the introduction of that defect into the software. Another big thing that we have is breaking builds. If we don't have context around change and we don't know how a defect was added to our software, and we don't know who did it, then we also have no idea who broke the build. We have no idea who broke the overall software system and caused things to not work across that system when they checked in their code. We also don't know if for some reason that breaking change that made it into the testing software, made it into the repository, if that then makes it into a production push of that code or that software to a production server or into a production build of the software, we don't know who broke it in production. And then again, we don't have any context as to how that defect entered into the software originally. And that leads us to a lack of chronology. Now, as I was talking about, we don't know who made the change, we don't know when they made the change, and we don't know how or when that defect was added to the software. So that comes down to chronology. In other words, having a timeline of change and modifications that have been made to our source code. And with that chronology, we then can identify different things. But one of the issues with not managing our source or not having a way to manage change across our source, we run into this lack of chronology. And when we don't have a chronology, we don't have a record of change, then we don't know at what time the defect was added, and we don't know in what order defects were added. The crazy thing is that software is so complex that when one defect is added, usually people are developing code off of the code that is defective. And so we can have a chain of defects that are all tied to each other and are all interdependent. And so if we don't know who made the change, we don't know when it was made, and we don't know when the defect was added, we have no way of figuring out what defects are reliant on other defects until we fix them and possibly break a whole bunch of additional things. We also don't know the context surrounding how or why the defect was added. So we don't know why that particular piece of code was changed. It might have been for a really good reason. It might have fixed another bug in some iteration from a bug that was added later on. And so if we change that code, we might actually introduce more bugs. If we don't have any notes or any information as to why it was made, then we may go in and fix that bug or revert that code to some other code, and then we might end up with old bugs returning back to the system. So having this chronology is super important for identifying defects, having a record of those defects, having notes about how and why the defect was added in order to complete a to-do item or add a feature. And that gives us a better ability to then reverse engineer that defect, find out what else it was dependent upon, or we would know about what other defects it was created to correct, if that makes sense. Then also, it's unclear as to whether or not additional code has become dependent on the defect. And I already kind of touched on that when we have chains of defects that are reliant on the code that was written by another defect. And that defect may have been created to correct a defect in the past that no longer exists because this code was introduced to fix this defect, and we now have another defect. So without a chronology, we actually have no way to determine if defects are dependent upon other defects and if defects were introduced to create or to fix other defects. So super important that we have a chronology, that we know when, who, and how, and why things were changed within our source. The next big one is the lack of change management. So we've kind of hit that a little bit, but what I really mean by that is that when we have developers working in the same source file, if we don't have a way to manage change when changes are submitted or entered into the source code, we could have a lot of overwrites, which means a developer finishes their code in this file prior to this developer finishing their code in the exact same file because they have copies of the original. And then they both need to submit, and let's say that this guy gets done first. He submits his code into wherever we're storing our code, some network folder or something. He enters all his code and submits it. Well, this guy doesn't know about the changes that this guy made. So after this is submitted, he still thinks that this is the original file that he pulled. He then copies over the top his file, which doesn't include the changes that this developer made, and we have overwrites. And when those overwrites happen, we end up with angry developers. We end up with developers that are extremely frustrated because all the hard work that they put in now is overridden by someone else. And then when that gets discovered, well, we have the other guy's code that was submitted after this guy, but now this guy who got done first is going to have to somehow work with this other guy to try to take the two different versions of that file and try to figure out how to integrate each other's code into that file and then have a combined file. In other words, merging conflicts end up, these overwrites, and a lot of angry developers. Well, with a loss of code, you end up having a loss of time, a loss of energy, and this loss of time and loss of energy equates to a loss of business opportunity. Pretty much every piece of software out there is built in order to provide business advantage to a business or to an entity or an organization. And when we have missed opportunity due to a lost time and code, that can negatively impact the business. It can really negatively impact the business. And so with that, we also end up with that lost time like we talked about, but we end up with missed deadlines. And those kind of relate to the same thing, that when we have missed deadlines, we have missed business opportunity, which negatively impacts the business or organization. The other big one we have is a loss of trust within the team. When team members don't trust that when they submit code, it isn't going to be overwritten by another teammate, or that they might end up with conflicts and all these kinds of problems. What we end up with is this lack of trust. And when developers don't trust each other, what ends up happening is they make copies of the source code, and then they just work within their own silos, and they do hundreds and thousands of lines of code, and they make tons of changes, which equates to hours upon hours of work. And then it becomes a race to who can submit before the other. And those usually happen after long periods of time. And so then if you have huge amounts of code that has been modified from the original by these two different developers, getting to a point after weeks and weeks of time and energy spent trying to take those two different code bases now and trying to merge them together without ending up with huge amounts of bugs, defects, problems, and just all kinds of duplicate features and stuff like that, we end up with this loss of trust, and we end up with huge amounts of business time lost and business opportunity lost because of all that lost time. So this is where having active change management becomes extremely important in the software development lifecycle. So what we do with that is we use some sort of tooling, some pieces of software or utilities that help us manage change. And that's exactly what Git is. Git is a change management solution, a utility that has been provided to us through an open source community where they decided to create a utility to solve a lot of these problems that we just went through, and they decided to name it Git. And so we're going to get into what Git is, how it works, to solve these specific problems. So as we learn Git, we're going to tie back those tools, utilities, and commands that we learn to these various problems